All right, so I'm going to go on a little bit of a tangent here. No surprise, I'm sure. But I am going to just work with numbers. So I'm going to take a number and I'm going to, what should this number be? I don't know, 70. So I'm going to take this number 70. And I'm going to try to factor 70. Now, what is my purpose here? Number one, my purpose is to sort of access what you already know. You know the number 70 really well. You also know how to factor 70. So what I'm going to do is I'm hoping to lay the groundwork so that you, instead of factoring 70, you can factor a polynomial that might look like this. Sorry, that should be a minus. Using the same sort of skills or just simply applying your knowledge. So I'm going to factor 70 in a different way. I'm going to factor it like we factor polynomials. And I am going to use the remainder theorem. I ask myself, what possibly could be a factor of 70? Now, 70, I'm going to go out on the limb. I'm going to take a guess. I'm going to say, is my factor 4? So I'm going to use the factor theorem, and I'm going to plug in 4 into my polynomial. And I know this doesn't work like this, but what I see is that my remainder is 2. More importantly, it's not 0. Therefore, I can conclude that I have a remainder, so 4 is not a factor. Okay, back to the drawing board. Sorry, my writing's so incredibly messy there. 4 is not a factor. So let me go over here. Now, I'm trying to pick a number. Well, how about 3? So I use the remainder theorem, and I see that when I plug in 3 into my polynomial, now what I'm doing here is just an imagined operation. So, 3. My remainder for 3 is actually 1. So since it's a non-zero, I can say 3 is not a factor. All right, let me wise up. I'm going to pick 2. Is 2 a factor? Well, my remainder, when I plug into my polynomial, my remainder is 0. So I actually think that, it's the factor theorem. Since my remainder is 0, I can conclude that 2 is a factor. So I know that 2 is a factor, really super important. So what do? I take 2 and I divide it into 70. Which leaves me with blah, 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 35. Now my remainder here should be 0 because that's what it is here. What can I conclude? That 70 is equal to 35 times 2, right? Our divisor times our quotient gives our dividend. So this is my polynomial. What is important to note is that 2 is my prime factor. So 2 is going to be there. I can't break up 2 anymore. However, I still have this composite number here, 35. In other words, there's probably more prime factors. And I know that you know how to factor 35, but this is just sort of accessing what you know already. Is there a factor of 35? Well, we can play these games already. We know that 4 is not a factor. We know that 3 is not a factor, so I'm not even going to consider that. And right now, you guys know, but we don't know, 2 might be a factor of 35, but you know in your heads right now that it's clearly not. So I'm just going to say I discover somehow that 5 is a factor of 35. So what do? I go 5 goes into 35 how many times? 7 times with a remainder of 0. So I'm breaking up 35, so I can conclude that 70 is 35, which is 5, or 7 times 5 times, right? That's 35 times 2. Since 7 is prime, 5 is prime, 2 is prime, I have factored 70 completely. Now, I'm going to do the same thing with polynomials.